Welcome to this lesson on BigQuery, Google Cloud's serverless data warehouse. BigQuery is one of the most powerful analytics tools in the Google Cloud Platform ecosystem. It combines the capabilities of a traditional data warehouse with the flexibility and scalability of cloud infrastructure. Throughout this lesson, we'll explore what makes BigQuery unique, how it works under the hood, and why it's become the go-to choice for organizations dealing with massive amounts of data. BigQuery is a fully managed, serverless enterprise data warehouse that enables scalable analysis over petabytes of data. Think of it as a massive spreadsheet on steroids that can handle billions of rows. It stores massive datasets efficiently, runs SQL queries at incredible scale, requires zero infrastructure management on your part, and even includes built-in machine learning capabilities. The key difference from traditional databases is that you don't need to set up servers, configure clusters, or hire database administrators. Google handles all of that complexity behind the scenes. The serverless architecture is what makes BigQuery truly revolutionary. You don't provision, manage, or scale any servers whatsoever. Resources scale automatically based on your workload, whether you're processing gigabytes or petabytes. You only pay for what you actually use, following a pay-per-use model. BigQuery provides high availability with built-in redundancy and disaster recovery, and Google manages all infrastructure updates and maintenance. This means you can focus entirely on analyzing your data and deriving insights, rather than worrying about hardware, capacity planning, or system administration. BigQuery consists of three key components working together. First is storage, which uses columnar storage with automatic compression to efficiently store your data. Second is the compute engine, which leverages Google's Dremel technology for distributed query processing. And third is the query service, which provides a standard SQL interface for data analysis. These components work in harmony but are separated architecturally, which means storage and compute can scale independently. This separation is crucial because it allows you to store massive amounts of data cheaply, while only paying for compute resources when you actually run queries. BigQuery's storage architecture is optimized specifically for analytical queries. It uses a columnar storage format, which means data is stored by column instead of by row. This is fundamentally different from traditional row-based databases. Why does this matter? Because analytical queries typically only need a few columns from tables with many columns. Columnar storage also enables automatic compression, which significantly reduces storage costs. Additionally, your data is automatically replicated across multiple zones for durability and high availability. You never have to worry about backups or data loss because Google handles all of that infrastructure for you. Query processing in BigQuery is powered by the Dremel engine, which Google developed specifically for this purpose. When you submit a SQL query, it goes through three main stages. First, the query is parsed, meaning it's analyzed and validated for correctness. Second, the work is distributed across potentially thousands of worker nodes in parallel. This is where the magic happens, as your single query gets broken down into many smaller pieces that can be processed simultaneously. Third, those parallel workers execute their portions, and the results are aggregated together. This massive parallel processing architecture is what allows BigQuery to scan billions of rows and return results in just seconds. BigQuery's pricing model has two main components. For storage, you pay for the data stored in your tables. Active storage costs 2 cents per gigabyte per month, while long-term storage, which is data that hasn't been modified in 90 days, costs just 1 cent per gigabyte per month. For compute, you have two options. On-demand pricing charges $5 per terabyte of data processed by your queries. Alternatively, flat-rate pricing lets you purchase monthly slots for predictable costs. This flexible pricing means small projects can start inexpensively with on-demand pricing, while large enterprises with consistent workloads can save money with flat-rate pricing. Data in BigQuery is organized in a three-level hierarchy. At the top level is the project, which is the top-level container for all your Google Cloud Platform resources. Within a project, you create datasets, which are logical groupings of tables and views. You can think of a dataset like a database or schema in traditional systems. Finally, tables contain the actual data stored in rows and columns. This hierarchical structure helps you organize your data logically, control access at different levels, and manage costs by separating data for different teams or applications. Understanding this hierarchy is essential for effectively working with BigQuery. BigQuery offers several powerful features beyond basic data warehousing. Built-in machine learning, known as BigQuery ML, lets you create and execute machine learning models using just SQL, without needing to export data or learn Python. Data integration capabilities allow you to connect BigQuery with cloud storage, Google Sheets, and Google Drive. Geospatial support enables you to analyze location data using specialized GIS functions built right into the platform. And BI integration means BigQuery works seamlessly with tools like Looker, Tableau, and Data Studio for visualization and reporting. These features make BigQuery a complete analytics platform, not just a database. BigQuery excels at several common use cases. Analytics dashboards can be powered by BigQuery to provide real-time business intelligence reporting across your organization. Log analysis becomes manageable at scale, allowing you to analyze application and system logs from thousands of servers. Customer analytics helps you understand user behavior and create detailed customer segmentation for marketing and product decisions. And predictive modeling enables you to build machine learning models for forecasting sales, predicting customer churn, or identifying fraud patterns. These use cases demonstrate BigQuery's versatility as a platform that goes far beyond simple data storage and retrieval.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.